Hello everyone. In this video, we will go over strategies of integration. Basically, this is overview of all the things we have learned. And now the question is in what order I should make this checklist and go one by one and see if that works for my integral or not. Okay, so as you know, the first thing that you must know is the table of integration or anything which is related to the table of integration. So you have to know table of integration by heart. Also, there are a few things that as we were working, we have added to the table. For example, things like integral of, let me start with this one that we had 1 over ax plus b dx. We know that this can be evaluated using substitution, but now you can have it on the table and this will give us ln of ax plus b. Let's see. Or something like dx over a squared plus x squared. So this is something that we did a study. Yes, you can use trig substitution, but now you can find it on the table and use it whenever you need it, just right away like that. Let me write a few more things here, something like this one also. This is 1 over 2a ln of x minus a over x plus a. And what else we had? We had some sine inverse versions. And okay, so let me do this one, x squared a squared minus x squared. You know how to integrate these ones, but these are the basic ones, and you can just use them whenever you need them. So here there's a condition that we should make sure that a is positive. Also, if there is this guy here, so it's x squared plus a squared, in that case you use a tan theta, or minus you use secant theta. In either case, this will give us x plus root x squared plus or minus a squared. So these are the things from the table, or extended table, let me tell you. After doing all these works that we have done now, you have these ones in the table, other than the basic examples that you had before. So that's the first starting point. So you should make sure that you know the items from the table of integration. But then the second thing that comes, you have to check. You look, well, your integral is not in the table. Then the first thing you have to start doing is simplify the integrand. So simplifying the integrand, or the function in the integral. Sometimes, well, it may look very strange, but when you do simplify, you will end up getting very easy integrals. For example, something like we had this example, some of them. For example, x plus 2 over say x cubed over this one. If you look at this, the way it is written, it might look like crazy things. So what I'm going to do? But the first thing here is that you look and try to simplify first, and then you see that, oh, this is just a simple integral. Or when you have trig functions, if the trig integrals are not as in the forms that we know, you may always look in the format. For example, here you see I can go ahead and write tan as a sine theta, or sine x over cosine x. And for secant, secant is 1 over cosine. Yes, 1 over secant squared will give us cosine squared x, yes. And that is where you see that the simplification plays a role. So you do get a very simple integral based on what we have learned. So simplification of the integrand is the first step you have to start with, okay? After the table, obviously. Then it comes time for the easy or obvious substitution. So substitutions. Well, things like when you have integral of derivative of something over that thing itself. That's one of the famous things that you do u equals to gx, and then this way you get ln of absolute value of gx plus c. Or for example, you have something like x over x squared minus 9 dx. In first look, you may say, okay, this is x squared minus a squared. I may need to use secant square 3 times secant square substitution. But here in this case, the derivative of the denominator basically is in the numerator. So x squared minus 9, then you will have half of ln of x squared minus 9. And so on. So substitution, the easy cases, especially if you have the derivative of the thing, or there's another format, for example, when you have e to the power, say, x squared x dx. Here also u equals to x squared would do the job for you and turn your integral to half of e to the power u du. And so on. So you have to have a good eyes for easy substitution. Then, after the substitution, you look for the different forms that we have covered. So look for the forms of integrand. Well, remember what we have covered. For example, we have covered, here I can write trig integrals. We had a full week of these ones. So integral of, I don't know, secant, powers of secant, and powers of tan, something like that, or powers of sine and cosine. These are the things that you have to now see and go for it. Okay. The other format that we had was trig substitutions, or even before that you can have integrals of the integrals with irrational form x squared minus a squared, or plus here, or a squared plus minus x squared. So this is, remember, the trig substitution. Again, we had a full lesson on this kind of integrals. Then the third format, which I would say go for, is rational functions. We had the whole work on this one. So remember the partial fraction thing, fraction decomposition. And some of the formats that you had in mind, or we have done for the integration by parts. Remember integrals like polynomial times e to the power x, or polynomial times, well, actually that could be mx and this could be sine mx, or integral of polynomial cosine mx and polynomial times ln x. All these that we have studied is another form that you have to be able to integrate. So all these ones you should go with, and then you have to be able to do. So when you get to this point and your integral is not any of the cases that we have covered so far, then you need to go back and think again. So before you tried obvious substitutions, or you tried obvious integration by parts. Now make it more difficult one. Try more difficult ones. So try again substitution and integration by parts. The others are not technique. The others are just different forms. But these two are the ones that you can work a little bit more with. So you can try a little bit more complicated cases, and you can try to see if by changing a little bit of function, manipulating algebraically the function, you can get one of the forms that you already know or not. So in several next videos, we will do some examples that we will need some strategy that we lay down right now here, and then you will see that the combinations of all these may come in. So we may need to first do a substitution and then integration by parts, and then come back to another substitution, then you have it in the table and so on. Okay? So you have to watch the other examples, other videos for more examples.